Okay guys, today we are going to review factoring from Algebra 1. Over the years I've found that not everybody learned to factor well when they were in Algebra 1, and even those that did are a little bit rusty on it by the time they get to Algebra 2. So we're going to spend several videos, which are, is the same as 2 class periods, reviewing factoring. So we're going to start out with some guidelines. And these guidelines basically tell you what kind of factoring to do in any given situation. So we're going to start out always, I don't care how many terms it's got, I don't care how many variables it's got, but you are always going to start out with the GCF, which is the greatest common factor. Then, after you have done the greatest common factor, then you're going to count how many terms you have in your polynomial. Basically, you're just looking for how many different things are added and subtracted together. So if you have 2 terms, you've got 2 options. The first would be to factor using the difference of squares. And the way that looks is if you've got something squared minus something else squared. The other option you have when you've got 2 terms, after you've done the greatest common factor, would be either the sum or difference of cubes. And for right now, that's all I'm going to say about the sum or difference of cubes. We're going to learn how to do that when we get to Chapter 5. I just want to go ahead and put it in our guidelines, but we're not going to talk about how to do it till we get there. Then, if you have 3 terms, there are 3 different types of factoring you might do. The first might be just a general trinomial. And that is when A is equal to 1. Now, this is basically like backwards FOIL. The other is going to be a general trinomial when A does not equal 1. The method for that, here's what I call it. I call that bottoms up. And you'll see how that works in just a few minutes, and I'll explain why I call it that. The last thing when you're given 3 terms after you've done the greatest common factor is to check and see if it is a perfect square trinomial. And I call that a square double square. And in a few minutes you'll see why I call it that. This one, the perfect square trinomial, will most likely be day 2. The 2 types of general trinomials, that will be part of day 1 factoring. And then the last type of factoring we're going to use is when you are given 4 or more terms, and that's when you're going to factor by grouping. So now, all of the examples I've pulled are not from your textbook. Okay, your textbook only gave about 4 examples total, and they didn't even review all of the types of factoring. So I have pulled lots of examples from lots of different places, and we're going to separate it out by type and get lots of practice. Okay? So where we start here for day 1 part of factoring is with GCF. Remember, that is greatest common factor. And this is basically like the backwards distributive property. Okay, so what I want to do here for problem number 1 is I want to look at my numbers. Since there's only a variable in one term, it's not common to both. I'm going to look at the numbers. What can I divide both of those numbers by? I can divide them both by 3. So what I'm going to do is I'm going to put 3 in front of my parentheses, and I'm going to undistribute the 3. Okay, basically I'm going to take and pull the 3 out. Basically all I'm doing is dividing both of those terms by 3 to figure out what goes in here. So when I take my first term and divide it by 3, I'm left with m. The second term, 12 divided by 3, gives me 4. This is your factored answer. The way to check it and see if you've done it correctly is to take and redistribute the 3 and see if you get what you started with. All right, problem number 2. I have numbers in 3 different terms. I also have an x variable in all 3 terms and a y variable in all 3 terms. So my GCF this time is going to be a little bit different. I'm going to have to work a little bit harder for it. So let's start with the numbers. If I look at my coefficients, 6, -2, and 6, all of those can be divided by 2. So I'm going to put a 2 out here. Then let's look at the x's. I've got an x to the second. This is an x to the first. And here, this is x to the third. I want to put my smallest exponent x out front. So that would be an x to the first. Then I'm going to look at the y's. I have a y to the second, a y to the second. This is also y to the first. You may want to write it up there so you don't forget. So once again, choose the y that has the smallest exponent. So that will be a y to the first out here. And I want to undistribute that from these 3 terms, which remember is just dividing each of those terms by 2xy. So for my first term, when I divide 6 divided by 2, I get 3. X squared divided by x is x. Y squared divided by y is y. Now let's move on to the second term. -2 divided by 2 is a -1. X to the first divided by x to the first, well, those are going to cancel each other out. And then y to the second divided by y to the first is y to the first. And my last term, 6 divided by 2, gives me a +3. X to the third divided by x gives me x to the second. Remember, we just subtract the exponents when it's a division problem. And then y to the first divided by y to the first, those are just going to cancel. So this is your factored answer. And now moving on to problem 3. At this point, I want you to pause the video, try to factor number 3, and then come back and check it with mine. All right, so I've got 3 different terms. I have coefficients for all 3 terms. The biggest number that will go into 10, 15, and 5 is a 5. Now I want to look at the A's. I've got an A to the third, A to the second, A to the first. So A to the first goes out here. I have a B to the second, B to the first, and b to the third. So b to the first goes outside. And now figure out what goes inside. So let's divide each of these terms by 5ab. So 10 divided by 5 is 2. I get an a squared and a b to the first. Here, 15 divided by 5 is a positive 3. I get an a to the first and the b's cancel. For my last term, negative 5 divided by 5 gives me negative 1. The a's will cancel and I get b squared. You can write the 1 coefficient, but you don't have to. This is your factored form. Alright, so we're going to stop this video here. Keep it nice and short, but I'll be back in just a few minutes with the other types of factoring.